Let's take a look at this problem. We want to solve. We got 4x squared equals 49. In general, a quadratic is of this form: ax squared plus bx plus c. For an example, you might have 7x squared plus 8x plus 2. Now this bx, this middle term right here, this kind of drives which technique to use, or partially drives that, I should say. So if you have bx, the middle term is known. I know it's starting to get late when I'm wondering if I'm spelling known correctly. Okay, if it is, these aren't technically the correct programming symbols here, but if you do have the middle term right here, then if it factors, excuse my poor writing, then we're going to use the zero factor property. Some books call that the zero product principle. There's a lot of different names I've seen for it. If it does not factor, then we're going to use quadratic formula. Technically, you could use a completeness square too, but quadratic formula is simpler. Okay, if we don't have the bx, so it's missing from the problem. And what I mean by missing is, see, if we had a problem that looked like this. We got 4x squared plus 8. Now we're going to see specifically, we're going to be solving these so that we're going to have this equal to 0. But if you're missing that middle term, then you want to use the square root property. So generally in solving, this is what we're dealing with. So let's go back to our problem then. And we got 4x squared equals 49. So maybe I can get back there. There we go. So 4x squared is equal to 49. Now you could have all different kinds of combinations. That's why I left it really vague up here and didn't put equal to 0. Because you could have the bx on the left side, on the right side. You could have the ax squared on either side of the equals. But specifically, we're missing our middle term. We don't got the bx. We got the x squared and we got the number, but not the x component. So that's right here. Bx is not known, so we're going to use the square root property. Now the square root property, if you remember, says, assuming I can spell, there we go. Square root property says, if you got something squared equal to something else. That's pretty vague, isn't it? But it really is that vague. You just have to have the entire left side squared, or whatever side it's on. Then you drop your squared, and you put a plus or minus square root around the other side. Now let's do that. Now ask yourself, is the entire left side squared here? Well, it isn't. Because remember, your exponent only affects what's to its immediate left, so it only affects the x. It doesn't affect the 4. So we're going to divide both sides by 4 to get the x part, or to get the x squared part by itself. So we're going to get x squared is equal to 49 over 4. Square root property says if you got something squared equal to something else, you drop your squared and you put a plus or minus square root around the other side. Okay, now let's talk a little bit about our simplifying techniques. When we're, in general, we're talking about fractions and radicals. We've got two main items. No fractions inside of a radical, and no radicals in a denominator. So those are our two main items we have to keep in mind when working with fractions and radicals. Well, if I come back here, we have a fraction inside of a radical. So that's no good. But we've got a property that says if you have a fraction inside of a radical, you can split it up. You can put a radical around top, radical around the bottom. In this case, we'll split it up and put a square root of 49 on top and square root of 4 down below. Which creates another issue, because we said right here that we can't have a radical in the denominator. But actually, when we split this up, square root of 49 is 7. Actually, let me show the steps. 49 is 7 times 7, and 4 is 2 times 2. And we're looking for pairs of something. Here's a pair of 7s, so those are going to come out as a single 7. And here's a pair of 2s, those are going to come out as a single 2. And that would be our answer. Technically, on this one, you did not have to split it up into a square root of top, square root of bottom, because this was 7 halves times 7 halves. I wanted to show this, though, just to refresh your memory, because you will have to do this potentially in another problem that does not work out nice, does not have a perfect number up here. Might be 13 up here. But that would be your answer.